Hey there, welcome to another college algebra video. We're doing 4.4 and 4.4 solves exponential and logarithmic equations. You can do two different types of exponential and two different types of logarithmic equations. And so this happens to be the one focusing on just the logarithms. Look for another video that deals with exponential equations. And so there are two different types of logarithmic equations. The first type is of the form log base b of something equals a constant. So there's not logarithms everywhere. So I'll call this not all logs. Okay, there's at least one element that doesn't have a logarithm in it. And so what our goal is our goal is to use the definition of logarithm, or what we call the transformation from logarithmic form to exponential form. And that way, if we're solving for a variable inside of the logarithm, when we switch it to exponential form, now it's outside the logarithm. There's no logarithm left, okay? And then we solve. Logarithmic equations, remember, logarithms have the domain of all positive numbers only, and so we have to check every solution at the end to make sure that we don't violate the domain. So there's a little bit of extra work sometimes for these logarithmic equations, but as long as you follow the steps, you should be fine. Okay, so example 1. Let's solve log base 2 of x minus 4 to the third power. This is already of the form a single logarithm equals a constant. That's the form. If you go back here, that's the form we're looking for. A single logarithm equals a constant. Okay, so we're in that form already. So what's the first step? The first step is to rewrite it in exponential form. So step 1 here, once you've got it in this form, step 1 is to write it in exponential form. What does that look like? The base is 2, and then the power is 3, and that equals x minus 4. Okay, so that's the first step, is to put it in exponential form. The second step is to solve. So we get 8 equals x minus 4, and that tells me that x equals 12. But now we always have to check. Always have to check. We don't have a choice. Okay, so come back to the original equation, log base 2 of 12 minus 4. What does that equal? That's log base 2 of 8. And what power of 2 gives you 8? The third power does. So it does check. Boom, we got it. So 12 is our answer. Perfectly good solution. And that's the way you do it. Okay? So, how do we handle problem number 2? Example 2 here, I'm going to get you started and I want you to finish it out. This is not in the right format because we have this 4 over here. So what we need to do is we need to divide both sides by 4 so that we just have natural log of 3x equals 2. 8 divided by 4 is 2. And then you want to think of this not as natural log, but as log base e, so that we don't forget the process of translating from logarithmic to exponential. Okay, so I've kind of given you a hint to get started. And so why don't you guys finish it out from here? Use the definition of logarithm, hit pause, and see if you can solve this. Okay, so what's the next step? The next step is to use exponential form, base e to the second power equals 3x. And then, of course, what do we need to do? We need to divide by 3 to solve for x. And so we get e squared over 3 equals x. That's my possible solution, but I still need to check. Go back to the original 4, natural log of 3, e squared over 3 equals 8. The 3 divides away the 3, and you get 4 natural log of e squared equals 8. How does the natural log of e squared work? That's the inverse property. Natural log of e to a power is just the power. And you get 4 times 2 equals 8, which of course is true. Checks. And so this is a perfectly good answer. All right. Now there's one more for us to try. I want you to try to hit pause and try this on your own. I'm not going to give you any hints other than the fact that, remember, what is your goal? Your goal is to get to the form of 1 logarithm equals a constant. 1 logarithm equals a constant. That's not what you have right here. But is there a way, is there something we've learned relatively recently that would allow you to rewrite this as 1 logarithm and then go from there? So hit the pause button and see what you can do. Okay, did you figure it out? How do we get these 2 logarithms into 1 logarithm? Yeah, the product rule, right? We're going to condense log x plus log x minus 3 is the same as log of x times x minus 3, product rule. That equals 1. And now this is no base, right? So that what means what? Base 10. Use the exponential form, 10 to the first power equals x times x minus 3. And now how do I solve this? Yeah, don't forget your skills, right? This is a quadratic. You have to distribute the x, set this equal to 0, and you get x squared minus 3x, subtract 10 and get minus 10. And so we end up with x minus 5 and x plus 2. And so here we get x equals 5, and here we get x equals negative 2. Now, remember, you have to test the domain, and the way that you do that is you plug it back into the original function, all the way back in the beginning. So we're going to plug in 5. You don't have to check whether it works, you just have to check really whether the domain's okay. Domain, positive, yes. 5 minus 3 is 2, positive, yes. We're good. So it checks. All right. How about the second one though? Log of minus 2 plus log of minus 2 minus 3 equals 1. Well, negative 2, negative 5, neither of those are any good, and so not okay. We got to put a line through here to get rid of x equal negative 2. Right? Make sure you don't erase this. I want to see that you found it. I just need notation that tells me that it's not part of your solution set though. All right, so checking x equal to 5 was fine. Checking x equal to negative 2 was not okay. So we threw it out and we got 1 answer left. If you throw out all of your answers, of course, you just report no solution as your answer. Okay? That's the first kind of logarithmic equations where you have at least one constant, or you can collect one constant to one side. The second type of logarithmic equation is what I'm going to call all logs, right? All logs go to heaven. All logs. Logarithms over here, logarithms over there. And if you have more than one on each side, then you condense it down into a single logarithm on each side. And then what we do is we use the one-to-one property. We are not dividing by logarithms. You can't do that. You're not allowed to. But because logarithms are one-to-one, if log base b of m equals log base b of n, then m and n are the same. You still have to check your answers at the end. Okay? So let me show you what I mean by that. Here we have 1 log equals 2 logs. All right, well, we can't do 2 equals 1. We have to do 1 equals 1. So I get log of x minus 3. And then how do I combine these two guys? I combine these with the quotient rule. I get 7x minus 23 on top and x plus 1 on the bottom. And so now I get log of stuff equals log of stuff. And so now this is where the one-to-one property comes in. The x minus 3 equals the 7x minus 23 all over x plus 1. Those are equal now without logarithm. Okay? Now, from here on, everything I do after this is all algebra. So if you have no trouble getting to here, if you understand getting to here, you understand the new stuff. But if you're struggling with solving for x from here, well, you got to go back to chapter 1. All right, and it's not been that long since we've done chapter 1, but you have to have that kind of stuff refreshed sometimes, and that's okay. There's nothing wrong with that, but make sure you do it. All right, so I'm going to multiply both sides by x plus 1 to divide that away from the denominator. Okay, and then I'm going to FOIL this out. And so I get x squared minus 3x plus 1 is minus 2x minus 3 That equals 7x minus 23, and then it's a quadratic, so I got to set it equal to 0. I subtract 7x from both sides to get negative 9x. I add 23 to both sides to get plus 20. That equals 0. This factors into x minus 5x minus 4, and so I get two answers, 5 and 4. All right, we should be used to by now knowing that that's not enough. We're going to go to the next page here. Right, we got x equals 5 and x equals 4 as our two possible solutions. We need to check them. And again, you don't have to go all the way through to check it. You do have to plug in to see in the original whether or not it will allow for the domain to be correct. So this is natural log of 2. That's okay. This is natural log of 35 minus 23, which is 12. That's okay. And this is natural log of 6. And so that's okay. What if we plug in 4? 4 minus 3, natural log of 7 times 4 minus 23. Minus natural log of 4 plus 1. This is 1, totally fine. This is 28 minus 3, which is 5, totally fine. This is 5, totally fine. So both check. So my answer is x equals 5 and 4, both. Certainly a possibility to have more than one answer. All right. So here's a very similar problem, a little bit easier even. Y'all give this a shot, see what you get. Okay, so what happens? You get log of x over 2x minus 5 equals log 8. That is the first step. You must combine. It must be 1 log equals 1 log. It cannot be more than 1. You can't divide by log. You can't, quote, cancel log. That doesn't work. But you can use the 1-to-1 property. 1 log on the left, 1 log on the right means that the stuff without the logarithms has to be equal also. And now we just do the algebra. So we multiply both sides by 2x minus 5 to divide that away. Distribute the 8. X equals 16x minus 40. Subtract 16x from both sides. Negative 15x equals negative 40. Divide by negative 15. Simplify, and you get x equals 40 over 15. Divide everything by 5, 8/3. So 8/3 is your final possible answer. We do have to check it. But here, if we plug in 8/3, we just get 8/3. That's good. How about the other one? If I plug that in, 2 times 8/3 minus 5, that's 16 over 3 minus 5. 5 is 15 over 3. And so that's 1/3, which is positive also, and that's fine. So again, you don't have to actually go all the way through this to figure it out. You do have to see whether the domain is good or not. You can check it all the way, obviously that's better, but all I need to see is that you've checked the domain for sure. Okay, so that's the way we do it. Come back for exponential equations in the next video.